So this question is sum of subarray range. So you're given the integer array. So what you need to do is you want to find out the difference between the largest and smallest element in the subarray, and you want to return the sum of all subarray range of the nums. So it's actually a continuous subarray. So you want to make sure that, you're catching this key point. So let's look at an example. So technically, this is straightforward. What you need to do is you're going to have a 2-pointer, right? So 1 pointer here, 1 pointer here, 1 pointer here, 1 pointer here. And so for this instance, your I and J pointer are pointing at the same index. So this is why your maximum and minimum are the same. So technically, you can ignore this scenario, right? What you need to do is you want to find out the length is greater than what 1, right? So this is going to be what the maximum is going to be 2, minimum is going to be 1. So 2 minus 1 equal to 1, and then this is going to be the same. 3 minus 2 equal to 1, and then this is going to be 3 minus 1 equal to 2, and then you add up. So let's just go into write down the solution for the brutal solution. So I'm going to return the long, right? So I'm going to say long result, and then I'm going to traverse I equal to 0, I less than num plus length, I plus plus. And then for int j equal to, so this is an example that we don't want to repeating using the I and j index. So it's going to be j equal to I plus 1, j less than nums dot length, and then j plus plus. So again, if you have j and also you are traversing in the I index, you can actually say I plus 1 less than the nums dot length, because you don't want to ignore your j, right? So your j and I always have their index to point at. So I still haven't specified the maximum and minimum. So this is why you want to declare every, so this scenario, the I is equal to 1, mean is equal to 1, max is equal to 2. This scenario like mean equal to 2, max is equal to 3. And this scenario is max equal to 3, mean equal to 1, right? So every single iteration you're updating the max and mean. So what you need to do is you want to just declare the mean equal to integer. So it's going to be not integer that means it's going to be represented nums I, and then max is equal to nums I again. This is because we were updating the value in a j pointer. J value. So it's going to be mean equal to math.mean nums j, and then mean, and then max is going to be the same, math.max nums j equal to max, and then you want to make sure result plus equal to max minus mean. So we declare mean and max as I, right? And then we find out, we want to find out mean and max for the j, right? For the j, and then we do the calculation. So in this scenario, should be okay. So the subarray has to be continuous, right? But it doesn't matter with the order. It doesn't matter with the, this going to be increasing order or decreasing order, but it has to be what in the subarray for in the continuous subarray. So let's run it and then submit. Yeah, this is going to be the easy solution that you traverse based on two pointer, and then we updating the min and max according to the j pointer, and then we initial in the I pointer, and then we're updating, right? This is the easy solution. This is everyone knows how to code. Alright, so the next one is going to be a challenge one that we want to optimize the complexity. So let's just look at the example again. So here's it. Alright, so okay. So in this example, they are not good enough, but I'm going to use example 3. So in example 3, so imagine you want to what? So this is going to be a subarray, right? A continuous subarray. All right. So your mean is this, max is this, right? So technically, you want to know like how many times you're reusing this element and reusing this element. So this is one scenario. I'm gonna leave this color, and this is gonna be another scenario, right? You always, you're using this for the mean again, this for the max, and then this is gonna be another iteration, right? You're gonna list this value as a mean, this value as a max. So the number of time that you're using on the left hand side and the right hand side, you want to know how many numbers that you use for this current value. And then it's going to be the same thing for the mean and for the max, right? So this is going to be a max value, and the number of times you use it in this, the red rectangle and then green rectangle, and maybe like there's another rectangle that you can be used, right? So maybe this one, the whole entire, right? So this is also considered, a way that we can optimize. So we calculate the frequency for this element on the left hand side and the right hand side, multiplied by its value, then it's going to be a total value for this. So just for example, I don't know what exact frequency this guy using. So for example, it's going to be 5. Maybe it's not a good color. All right. So for example, you use this number for 5 times, right? So it's going to be 5 times -3, 15, -15, right? So in terms of that, like this value for the positive 4, you probably need 7 times, right? I don't know the exact number, but 7 times positive 4 is going to be 28. And then you do the, it's going to be max minus mean later on, right? Largest minus smallest. So it's 28 minus 15, something like this. And then you want to get 13, right? So, I mean, this is not a solution, but I'm just telling you the approach, all right? So the number of time for the maximum use, number of time for the minimum use, subtract, and you get a result. All right, and there are a lot of Subarray you can count into that, but let's just write down the solution because we already know the idea. We want to make sure we have 2 different stacks. One is going to be max, the other one is going to be mean, and then we are going to repeat it using until the array is finished, right? So yeah, this is going to be hard, but I'm telling you like follow along. So I'm going to declare the stack for here, mean and max, and then initialize mean. Oh, and declare the max. So what I need to do, I want to have a result for return. Alright, so I'm going to traverse my nums array. Alright, so in this scenario, like I will tell you why do we need to have a less than equal over here, but let's just keep in mind, I'm going to say to do explain less than equal. Okay. Alright, so now we want to make sure the solution is going to be maximum minus mean, right? Largest minus smallest. So result is going to be plus equal. It's going to be maximum minus mean, right? So how do I, so probably need to write a function. So public, private, doesn't matter, lone, and I'm going to say process stack, stack procedure, something like this. I don't know. All right. So I'm going to have a stack. So stack is going to be here, and then I need to declare which one is it. All right. So it's going to be stack. All right. I need to know what's my array. I need to know what index I'm currently traversing. Okay, so now if I want to use the stack and I want to apply the by function, which is going to be lambda, so by function. And I'm comparing with what? Integer and integer, right? And I'm returning a boolean. So let's just do this. Okay. All right, let's do this. So what I'm doing is I already know what this function doing, so it's going to be stack procedure. So in this case, I'm going to say max. I'm going to say this is going to be maximum, right? So largest, So what do I need to pass in the nums? I need to pass in the I. Okay, I need to pass in the lambda expression. It's going to be a comma b. So if this is going to be maximum, you want to know it's going to be increasing order, right? So yeah, just increasing order. I'll explain why. All right. So in this case, you want to minus, probably the same thing, but it's going to be mean. And this is going to be what? Decreasing order. So what does what does A and B represent? A and B represented by function. And I will have to write a method that declare how I define the compare. Because at this moment you don't know A, you don't know B, and you don't know how did I compare, right? So wait, let me put this back here. So if this is the case, I probably just put it right here, and comma, and then do this. So I'm declaring the value for the stack. All right, so yeah, pretty much it. All right, now I need to write my sub function. So sub function is going to be result equal to 0, return result. And then, so again, why do I need to write this function? I want to push every index into the stack if and only if you find out. So what does max represent? It's going to be increasing order. And this is going to be, this is going to be what? The order that you want to find out the largest, right? So what does largest represent? So imagine you have what? Let's look at this. So what does, in order to satisfy list A less than B, this is going to be increasing order. So 1, 2, 3, this is increasing order, right? All right, in order to find out the largest, we want to say, oh, the value that we are, traverse is 1, but the next value is going to be 2, right? 2 is definitely greater than 1, and then we want to find out the largest one. It has to be satisfied 1 less than 2, right? This is going to be the value that we want to find out the largest, right? So this logic is a little bit tricky, but whatever. All right, so cancel. Okay. All right. So in order to find out the largest one, and then you want to make sure the stack is not empty. All right. So while stack is not empty, what you need to do is you want to find the max, the current max in stack, and then find the previous one in stack, and then calculate the number of times it used, right? All right, but this is going to be a calculation part. But whatever, I mean, in this function, whatsoever you still need to push into your, your index into the stack at the end for the next iteration purpose, right? For the next iteration purpose. So in this one, I'm using the max. This is because I'm doing this. And then if you're doing this, then you want to change the idea to mean. All right. So I'm going to delete this. So while stack is not empty, all right? And also, you want to do this. So let me do this. X, I'm going to do this. I will define, hold on, n. This is n. If stack is not empty, n. So I will define this later, but let me define what is compare. So compare has to be applied. So this is going to be A, this is going to be B. The return result is going to be Boolean, right? So what is, A comma B? Like, what is this? A represent the value that we want to, pick in a stack. So num sub stack.pick. And this value B represent the num set I. So for example, num sub pick, which is 1, and the next iteration, which is I equal to 1, num set 1 equal to 2, right? So 1, comma 2, when you compare the apply, this is satisfy the constraint, right? So you want to get this idea. Okay. So once we have this, we want to find out the pop index. So I'm say pop index. It's going to be stack.pop. And also, what is the value that before this pop index? You want to find out the distance, right? The distance. So let me. So it's going to be stack.p, right? But this is not the solution, because what happened, like you just add it, you add the value one in the stack. On the next iteration, you want to pop, and then you also want to find out the previous index, right? But in the stack, you only have one, right? So you want to declare a constraint. So if stack is empty, then you want to return -1, else stack.p. So -1 will actually avoid, overflow. And also you want to do the calculation between the left side and right hand side. This will also giving you a 0 if you want to do this. So it's going to be result plus equal. So the current value represents nums at I, right? But you want to cast too long, so 1L times nums at I times. All right, now this is going to be tricky part. So you want to times the left hand side and right hand side, right? So what is left hand side? Left hand side is going to be the pop index minus prev index. All right, so what is the right hand side? Right hand side is going to be the current position I minus the pop index. So this is a trick. If I have to explain this logic, I probably have to explain that another 20 minutes or so, but I don't want to do this. And just if you don't know, write on the paper and then try to understand that why do I need to have this constraint. All right, so this is going to be left hand side. How many times you use on the left left rectangle that I show you, and this is going to be how many times you want to use on the right rectangle. So left hand side, right hand side, and this is going to be your current value. So let's think about this. And think about this. So if your value that is, think about it. If you just add a value for the last value, add an index for the last value, you're not actually using that, right? You are just adding into a stack, but you are not using that as the algorithm. So when I do this less than equal, this is actually trying to find out what is the value for the current value. Sorry, let me do this. So 1, 2, 3. So you add this one, and then you find out the in and max, min and max, and you add this one, and you find out min and max. But when you add this one, you're still not using the min and max, right? But you want to count this value into our algorithm, right? And then in order to do this, we want to fake the value. So we want to actually hit this point, and then you want to make sure if I is equal to num.length, then you want to count this into the method. So it's going to be I equal to num.length. All right, so this is whole entire solution, so it should be okay. Okay, not okay. So okay, so this is not nums.I. It should be pop index, right? The index that we use. So this is a typo. So my bad. Okay. All right, this is solution. So again, the pop index is actually representing, like I promise I explained this again before. So for example, this is a pop index. Oh, maybe this is not a good one. Which one is the good one? I don't know. Should be, this example is pretty bad. All right, imagine we're looking at this solution, and 1 is the current value, but the pop index should be represent what? -3, right? And the -3, we want to find out how many time like you want to use this value. So technically, the array you are looking is what? You want to look at the -3. So for example, you are using this as a subarray. You want to know how many times. So this is going to be 2 times, and this is going to be another time that you use. So how many times for this value, right? So at this moment you have to calculate the left hand side, and also you want to do the right hand side as well. Okay, so yeah, there's a solution for time and space. For this one, this is all of n, and this is all of constant for sure. But you know, people say this is constant, so the whole entire time complexity is going to be all of n. But I would say it's going to be slightly to kn. K represent constant, but it defines how many times you use it for this while loop. So the previous solution I have, I think it's this one. So this solution is going to be time. Time is going to be n squared. Space is going to be constant, and in this solution, space is going to be all of n, time is going to be all of n as well. So the reason why I'm using this stack procedure is what? Let me take a look for other solutions. So I'm using someone else example. All right, so yeah, left hand side, right hand side. So this is the idea that you can consider. So maybe this is maybe someone else. Probably this one. Okay, so this is repeating code, right? The only thing that you change is the stack. So in order to satisfy this constraint, it's better to use by function, and you have to know how to use it. So you can repeating this block of code and this block of code into one method, and then you will have a better line of code in the project. All right. Anyway, all right. I hope you get it, and then if you don't, leave a comment, and I'll see you later. Bye.